In this video, I'm going to show you how to calculate binomial probabilities in R. So if we go to R, and first thing I'll set my working directory. And then we'll start with a simple example where we are trying to figure out the probability that 3 wasps are male out of a sample of 5 wasps if the probability of being male in the population is 0.2. And so we're going to set some variables here. So n is the size of the sample, 5. X is going to be a measure of how many wasps are male in the sample, and then p is the probability of a wasp being male in the population. And then once I've set those 3 variables there, I can apply the binomial probability formula to calculate the probability that 3 wasps are male out of a sample of 5 wasps. And that formula, I'll just run through this here. So we've got this part here, choose nx, so that's the binomial coefficient for the number of ways of choosing x objects out of a sample of n. So how many ways to select 3 objects in a sample of 5 objects. So I could just run that separately. So we can see that there's 10 different ways of doing that. And then this part of the formula is 0.2 cubed. So I could run that separately. And this part of the formula is 1 minus p to the n minus x, so 0.8 squared. So that's 0.64. And if I multiply those 3 numbers together, I get 0.0512. There's an inbuilt function in R, as there is for a lot of things, that does this calculation for you without you having to remember the formula. And that uses the binom package. So we'll install that first and load it. And then I can run this function. And if you're ever curious about how to use a function, you can always look it up in the help over here. So if I type dbinom here, it'll prompt me, and here's a description of that function, and it tells you the arguments, what the definitions are, gives you the details of what it's doing, and tells you what it's going to return. And then usually at the bottom there's some example code that you can use. So in this case, first argument x is the number of wasps in my sample that I'm trying to figure out the probability of them being male. Size is the sample size, and then prob is the probability, which in this case is the probability of being male. So if I run that, I get the same answer that I did before. So let's revisit that example from the previous lesson where we were looking at the genetics of mirror image flowers. And when we were looking at hypothesis testing, one thing we needed to figure out was the probability of getting 6 left-handed flowers out of a sample of 27 flowers if the probability of a left-handed flower is 0.25 in the population. So this is a binomial situation. So in the previous lesson we ran a simulation to try and calculate this null distribution. Turns out we didn't actually need to do that because we can obtain the true probability distribution using statistical theory. In particular, we know it's a binomial distribution, and we know what the formula is to calculate those probabilities. So I just run the same code I did before, changing the values of n, x, and p, and I can find that the probability that I'm interested in is 0.171883. And again, we can use the dbinom function to get it directly. The nice thing about functions like this is I can actually calculate a whole series of probabilities with a single line of code. And this is a really nice feature of R, and it's one of its advantages over other software packages. So if I set up a vector representing the number of binomial successes, which in this case is number of wasps that are not wasps, we're on the flower example, number of flowers that are left-handed, then if we just take a look at what I just created, oops, I didn't mean to do that, I meant to do this. It's just a vector going from 0 consecutively up to n. Okay, so it's the number 0, 1, 2, 3, 4, and so on all the way up to 27. N is 27. And then now I can run this piece of code here using that vector as the first argument. And the size argument is the same as before, sample size, and then the prob argument is the probability of being left-handed. But if I put a vector in here for the first argument, what's going to happen internally is R is going to run this function for every value in this vector, and then it's going to return a vector with the result of this calculation for each value of X successes. Let me do that so you can see what it's doing. Okay, and then before I actually look at the results, I'm just going to turn this into a data frame, and the reason I do that is just because it formats the results a little nicer. So if we look at the results, we've got two columns here, and we've got the number of successes in the first column, so 0 up to 27, and then we've got these probabilities that it's calculated here. Because some of these numbers are very small, it's put this into scientific notation. So let me see if I can just fix that up and round. I might have to experiment a little bit here. Oh no, it worked okay. Okay, so here's my probabilities without this clunky scientific notation here. So I've got probability 0.0004 of observing 0 left-handed flowers in a sample of size 27 if the probability of a left-handed flower in the population is 0.25, and then 0.0038 of getting one left-handed flower, and so on. Here's the number that we calculated before for 6 flowers. That was this number up here. Okay, and it goes all the way up to 27. And then now that I have all those probabilities, I could draw a histogram of the distribution, except I haven't installed the library yet. So let me install the ggplot2 package, set the theme, and then let's look at the plot. Okay, so there's the plot there, the histogram of this distribution. And just while I notice it here, when you're first using R, you can get a little freaked out with these error messages because they can be a little bit obscure. My experience with students learning R for the first time is that they can be so freaked out by these error messages that they throw up their hands and go, oh my god, I don't know what to do now. But if you just take the time to actually read the error message, even if there's like odd bits of code in there that you don't understand, the error message usually tells you what the problem is. And here it's saying error, could not find this function. Okay, and that should give you a clue as to how to fix the problem. And I knew right away that the problem was, the reason it can't find this function is because I forgot to load the package. So all I had to do was to go back up and go, okay, if I load the package, then it's going to be able to find the function, and then it ran the function, no problem. So it's a good thing to keep in mind when you're using R, and it gives you error messages because it will. Doesn't matter how experienced a coder you are, you'll always make little mistakes. Like I just made a little mistake. I've been using R for years, and I get error messages all the time. So don't be freaked out by them. see if you can discern what the issue is from what the error message is, and away you go. And if you can't figure out what the problem is, you could always just copy this code, put it into Google, and see if someone else can figure out what the problem is. So, and then the other thing to try, of course, is to go to the help facility over here, and if I just type in ggplot, okay, it'll tell me at the top ggplot, and then in these curly brackets here, it tells me the package that function lives in. And so if you've not installed or loaded this package, R isn't going to be able to find that function. If you actually don't have this package installed, when you type this in here, it's not even going to find this help function. So that's another clue that you need to find the package that it's in, is if you type the name of a function in here and R can't even find it, that means you haven't even installed the package. So we covered binomial probabilities in this video, and in the next video we'll go on to use a binomial test for a proportion, which unsurprisingly uses the binomial distribution.